Welcome back. We're going to delve into namespaces, templates, and the standard template library and its contents today. It's quite a depth of material, so we're just going to get a bit of a tasting of these things. But for more information, you can always look up more about each of these three things as well. So, starting with namespaces, we're going to make a namespace called geography and put some stuff in it. You can do literally anything that you want to, but we're just going to make some constant values just for the sake of exercise. So, inside of week 10, I'm going to have example 1. And for all of the exercises for this set of exercises, we're just going to limit ourselves to one CPP file at a time. Maybe it's the case that you could consider splitting some of these off, especially as we get to the later exercises and the code gets pretty deep. But this is mostly for the purpose of demonstrating the different namespace template and standard template library stuff. So it's probably okay not to build whole header files for all of these sorts of things. Okay, so we need a namespace called geography. So we kind of set it up the way you would set up a class, namespace, geography, and braces. Now, the way that this works, first of all, I'm not going to have a semicolon after. I'm just going to say namespace geography. And now everything inside of here is part of the geography namespace and is only accessible if I am grabbing the geography namespace. So let's say, for instance, that I want to make okay, first let's include some things. Any IO stream. And here we're going to definitely not use the namespace STD. All kinds of weird stuff could happen if we do that, so we're not going to. What we will do, however, is we will make a, I suppose, let's make a constant value. So let's make a int highest, and it's so the highest point on Earth. Let's do it as a float. And so just looking up what that is, 8.848, and this is kilometers, is the highest point on Earth, and the longest river is 6650, also kilometers. And we can have a string highest point equals Everest. And we can have a string longest river equals Nile. So here's our namespace. And then inside of main, if I want to retrieve these things, I can do something like cout the highest point is highest point, which is highest kilometers, and the longest river is, which is, longest kilometers. Okay, that's it. So, now, I've already goofed the thing that we're doing. Let me show you why this won't work. So if I go here, and I try to compile, and it's very confused. And it's like, did you mean the geography's highest point, the geography's highest, the geography's longest river? So because these aren't within the global namespace, they're only within the geography namespace, I can't grab highest point, longest river, longest or highest, without specifying I mean this namespace. This namespace, this namespace, this namespace. Same as cout is not known to the computer unless I tell it I'm looking at the standard namespace. Highest point's not known unless I tell I'm looking at the geography namespace. And if I am, it says, oh, okay, I understand perfectly. Yeah, okay. Not a problem. So there we have it. And that's our first little exercise before we move on. Okay. Inside geography, make a topography namespace with string constants representing different geological formations like mountain, valley, and plain. In my main program, make a namespace alias topo for topography, and use this alias to access the constants. So let's try this out. we're going to duplicate into exercise 2. Okay, so you can make a namespace and a namespace. Not too surprising. We'll call it topography because it says so. And in here, it says make some string constants. So string mountain, which is mountain, valley, and plain. We'll comment this out for now. However, if I want to access mountain, I have to go geography : topography : mountain. This is a mouthful. So to shorten it, you can do what's called a namespace alias, and it's essentially telling the computer to shortcut these names into something simpler. So in this case, I want something called topo, and it's going to be geography topography, the namespace. Which means now, instead of having to put geography topography all the time, I can just do something like cout mountain, topo : mountain, and valley, and plain. Now I got my mountain, valley, and plain. So this is really handy, especially as some of these namespaces get really, really deep and you end up building lots and lots of them upon each other. But this can be very important if, for instance, there's a difference between the geography topography mountain and a mountain that you're talking about for some other purpose, maybe for something to do with mining, I don't know. But very often, for instance, something like highest or longest might be something that differs depending on the context in which you're working. And so it's very useful to be able to reuse some of these names as long as you're specifying where they're coming from. This highest has to do with geography, not with the tallest person in the room or something like that. And there we have it. Okay, so pretty short, but that gets the point across before we move on. Okay. Within the same topography namespace, define several functions that provide general information about the geological formations. In your main program, use the using directive, which we've seen before for using namespace std, to bring in specific functions from the topography namespace and call them without namespace qualification. So, I'm going to duplicate this as well. Exercise 3. Here's our new instructions. And so here, inside my topography, we'll get some functions like void describe mountain. And I have my little wiki-generated description of what this is. And so this is going to output mountains are elevated landforms with steep slopes and peaks. That's a mountain. And then I can describe a valley and also describe a plain. Looking at my quick wiki pull-up, valleys are low-lying areas between mountains or hills, often with rivers or streams. And finally, plains. Plains are flat, low-lying areas with gentle slopes, usually covered by grass or crops. All right, there we go. I got some methods. So I could do topo : describe mountain, but sometimes, if you realize that you're going to be constantly working in a namespace for the majority of a file, you can at times use the using directive to make things a little bit simpler. And so where I would put this is right above where I plan to be for the rest of the program dealing with that namespace. So instead, I can say using namespace geography : topography. And now I don't need to specify this topo anymore. And I can do simply something like describe mountain, describe valley, describe plain, without having to reference the namespace because I've specified for the rest of the program starting from here, I'm always using that namespace. Compile exercise 3 and go. And there are our descriptions along with our words. All right, moving on. Okay, create a template class. So here we're getting into templates called coordinate inside the geography namespace. It should have a class constructor that either takes one float, such as degrees, or takes 3 integers representing degrees, minutes, and seconds. For the float option, minutes and seconds should be 0. And so this kind of reflects, the different ways that you can represent a coordinate on the world. Is either you can give it degrees, minutes, and seconds, or you can just say, blank degrees. And this would be specifically for a latitude coordinate or a longitude coordinate. You would probably need 2 coordinates for an actual place. So, continuing with our duplications, moving on to exercise 4. Okay, so this is going to be in our geography namespace. So we'll put it right above topography, but below our little constants here. So, a template class. What is a template class? Basically, a template class is a class where the type of one of the variables is actually something that can vary from object to object. So far, when we made our classes, for instance, when we made our art objects, for instance, all of our art was required exactly specific things set in line. You needed to have a string for the artist, you needed a string for the title, integer for the year, and so on. But what if it's the case that you want to have multiple different types? So in this scenario, for instance, we're going to make a coordinate class that either could have a float or could have integers. So here's what it's going to look like. First off, if you want to make a template class, you need to write the word template. You can see it turns in bold. And for this scenario, I want to have a generic type t. And so t could be technically anything, but in this case, I mostly just want it to be either a floating point number or an integer. But t here I'm writing in to indicate that this is a substitute for whatever is the appropriate type. Whenever you see t in my class description, it means whatever that type happens to be. So now I'm going to have a coordinate class. And in my coordinate class, I'll have my private variables. In this case, that's my degrees, my minutes, and my seconds. But here's the thing, is what is the type of this? Well, it could be a float or it could be an int. I can't write either or both. But what I can do is I can write t. So this means that whatever the type of object I have, it either could be degrees with floating points or it could be degrees with integers. For my own peace of mind, so I know which one I'm dealing with, I'm going to have a Boolean called is degrees, minutes, seconds. And this will tell me if it is degrees and minutes and seconds versus if it's just a single floating point number. Now, I'm going to need 2 constructors for this. Let's tab this all over. I want one constructor in case it's a floating point number. So if it is, I got my coordinate t degrees. And so this is in the scenario where I try to build a coordinate, just giving it one thing. That usually means I'm giving it the degrees in float. So that will be set the degrees to be that. And it says that the minutes should be 0. And the seconds should be 0. Is DMS is false. It's not degrees, minutes, and seconds, just the degree. And then I'll have my second constructor here, but my second constructor will take degrees, minutes, and seconds. These are all the same type because they're all going to be integers. And so then I have my degrees, my minutes, my seconds, and this one is degrees, minutes, seconds. So those are my 2 constructors for it. Then I'm going to make a method to print them out. So we'll call this void print. If it is DMS, then I'll print out degrees, comma, minutes, minutes, seconds, seconds. Okay. If it's not degrees, minutes, seconds, then all it is degrees, and I'll cut away the rest. So now let's make some coordinates. We'll get rid of this other stuff in the main file for now. So let's make a, first off, if we want to make a coordinate, we have to specify it's in the geography namespace. This is a geography : coordinate. Note that even though I'm using the namespace geography topography, this doesn't mean I have access to everything in geography. It only means I have everything in topography, which means that coordinate is not already here. I have to actually specify this. So this is going to be what kind of coordinate? Well, we'll do one with a floating point number. So note that I have to put the triangle brackets here to create an object of this type because it's asking me, well, what is t? I wrote t a whole bunch of times in this class description, but I need to tell it what it is. And in this case, I want that to be a floating point number. And so this will be my lat float, for example. And we can say, 37.77. And I can do lat float dot print. And then I'll do it the second time, but this time let's do long lat int instead of lat float. And now I have to give it 3 numbers. And now the nice thing is I only had to make one class. I have a single coordinate class, but I can have 2 different constructors for it that will now treat things in 2 different ways. And when we run this, you can see that it will print the floating point version with just a single one, and it will print the one with 3 numbers in a different way, which is kind of handy. So there we have it. And just to demonstrate, if I remove the geography from here, it is unsure about what a coordinate is because it doesn't know that you're in that namespace. So it's important to have that sticking around. All right, we're halfway through and going fast. So don't feel bad if you have to pause and go back, but we're going to move right on to our next exercise. Okay. Create a specialized version of the coordinate template class for the string data type that parses a string such as 65, 45, 39 into degrees, minutes, and seconds. Include sstream and use this constructor. Okay, so we're going to definitely need to grab all this because that's going to be important. Okay, so this is our constructor that we're going to need. And so the idea here is that we're going to make a template specialization. And this basically means that although we have one version of our class described here, we're actually going to make a second one right underneath it. And this one is also going to be a template class, but this time we're actually not going to give it a type name T or anything like that because this is specifically going to be a version of the coordinate class that is a string. It takes a string as its parameter. And here's how it's going to look. So we're going to copy some things from before. Our private stuff is still there. We don't need to have this Boolean anymore. We know that it's going to be a string version, so it's always going to have the degrees, minutes, and seconds. Our constructor is very easy because it's given to us. Here it is. Yoink. Let's take a look at this constructor for a second, though. It's kind of a handy shortcut into what we want to do with it. It takes a string as a parameter, and what it does is, or I guess a reference to a string more specifically, and what it does is it creates a input string stream. And so what this means is that the same way that we read from a file, read from the keyboard, you can also read from a string. So if you thought of, for instance, a file containing 65, 45, 39, if there was a file containing this, well, how would you read it? You could use getLine, which is, I guess, one way, but then you would be reading it all at once. If you use the arrows, how does it work? Well, if you remember from way back when we first learned files, using the arrows grabs each word independently. So 65 is the first word, 45 is the next one, and 39. So using arrows, we're going to direct the first word into degrees, the second word into minutes, and the third word into seconds. This is a kind of neat little shortcut, something you might not see all the time, that helps us to very quickly transmute the string here into our degrees, minutes, and seconds. And then our print is very simple. It's the same from before, just we don't have to do any checking of things because we already know exactly what it is. Get rid of that completely. Okay. And now down here, we'll make another geography coordinate. But this time, and this time we're not dealing with t degrees, minutes, or seconds. It should be int degrees, int minutes, int seconds. And we're going to make a coordinate string, lat str, that has our numbers, was it 65, 45, 39? Yeah, that's right. And we'll print out lat star. Let's try it. Oh, I messed something up. Oh, I forgot to put the geography name. Where did I put? Where is this? Oh, I'm compiling the wrong thing. At least I think I am. No, that's not right. That's from before. I fixed that. I'm looking at the wrong error message. Let's try this again. What is the actual error message? Input stream ISS has initializer but incomplete type. Okay, that's odd. Incomplete type. Oh, I forgot to include the thing it said to include. Include stream. There we go. No matching call for this. Oh, because I put in the numbers, but it's supposed to be quotes. This is how we're supposed to read it in, right? There we go. I put in the numbers, so I was just mindlessly copying this, but this is how the string is supposed to be read in. So I can take this string, put it into my coordinate, and create one. Okay, let's try that out. There we go. And hooray, it does exactly the same thing as the other one, except this time now our class is able to take in a string and convert it into the degrees, minutes, and seconds. Nice. All right, let's move on. Okay. Create a location class in geography that has an array of 2 coordinates and a name. Utilize the standard template library's map container to store location objects. Use the name of the location as the key and the array pointer as the value. Okay, so this is a much deeper exercise than some of the others we've done so far. Quite a bit's going to have to happen, but I think we should be able to get by it okay. All right, so let's break down all the things we have to do. We have to make a location class in geography that has an array of 2 coordinates and a name. Okay, so let's do that first. In order to make a location class that has coordinates, we need the coordinates to exist first. So, okay, we got our coordinates, they're up there. Now we can make our location class, and our location class, because it depends on coordinates, and coordinates could have any type, means that our location class also needs to be a template class. So our template class here also is going to have type name t, and we'll have a class called location. It's going to have private and public members. The private members it's going to need to have a name because it said so, and it's going to need to have a coordinate array. So what is the type? Well, it's t. And specifically this is going to have, if we want to put things in here, we probably should make it pointers to coordinates as opposed to putting the actual coordinate objects in here. And so these are going to be our coordinates, and there are 2 of them. So these are pointers to two coordinates, which we'll make dynamically. Now, publicly speaking, we need to have a constructor. Our constructor for our location is going to need to include a name. It's going to need to have a coordinate pointer, which is the latitude. And it's going to need to have a coordinate pointer to the longitude. The name is going to be associated, and then I can't use the shorthand to put these in the correct places, so what I actually need to do is say coordinates 0 equals lat, coordinates 1 equals long. But there we have it. So now I have a class that represents an actual place. It has a name, it has the location of it in terms of its coordinates, a latitude and a longitude, and let's give it a little printer thing to say where this is. So I print cout name is located at latitude. So we'll do a new line, and then we will do coordinates 0 dot print. And we will do latitude blank and longitude, print that. Okay. Now, let's, what else do we have to do? So we did that. Use the map container to store location objects using the name of the location as the key and the array pointer as the value. Okay, so to do that, there's a few things that we're going to want to do in our main function. Starting with, we're going to get rid of most of this. I suppose what we'll do is we will get rid of these ones. We'll keep the floating point one around, but we'll make a second one, which is the long float. Minus 122 or something like that. 22. And we'll do long float. I guess we don't need to print them, because what we're going to do is we're going to make these. I just want to comment it. We're going to make these, and then we're going to pass them to a new location. Now, writing geography : coordinate, geography : location a million times can be kind of annoying. So we're going to shorten this a little bit. And so what we'll do is we're going to do what's called a type def. So type def allows us to create our own type, which is just a shorthand for something else. So here is the type that we want. It's a floating point coordinate from the geography namespace. And we'll call this a float coord, just to make it a little shorter. And then we'll define a location that also takes a floating point number as a float location. And now I don't have to write this whole blob here. I can just write float coord or float location. So this float coord, and this is actually going to be a pointer called lat float equals new float coord. And similarly here, float coord long float equals new float coord here. So now I have pointers to two dynamically created floating point coordinates, and I can put them into a location. So I can say float location, and this also I think I have to do dynamically. And in fact, actually what I can do is rather than making a variable, let's put it into a map. So a map is a dictionary if you're familiar with Python. It's an std map, and I can make one by specifying what the types are going to be. So it said that the key is the name of the location and the array pointer is the value. So the key is a string, and the the value is a location. So let's say float location in this case. And we will call this places, because that's what it represents. But now I can say places and subscript New York is a new float location where I give it the name New York, and I give it lat float, and I give it long float. And now what I can do is I can do something like places access New York dot print, and we'll see what happens. Oops, let's see here. I missed a comma. So this is in my up here. Let me take a look. What else does it say the other errors are? Expected primary expression. Well, that's because this thing messed up for some reason. I wonder. Oh, I've been using long as a name. Like I don't think I can. Long is a variable type. It's like trying to name a variable int. So let's make this, instead of long, we'll make this lng, and this will be lng, and that should hopefully fix that issue. Okay, but I got new errors. Map is not part of the standard library. No, unless you include the right library, which is include map. Okay, something else is very wrong. Let's take a look. Ooh, that's a lot. No match for operator equals. Okay, so I think I messed up because I said that it's going to be a floating location, but it's not. It's a floating location pointer. So it should have an asterisk. Almost there. Oh, yep. I meant to use the arrow, and I used a dot. And this is a pointer, so I can't do that, which means that this needs to change. Arrow. Okay. Now what? Same thing. They're pointers, so these should be arrows. Pointers, so it should be an arrow. Okay, we did it. New York is located at latitude, this one, and longitude, this one. Hooray, I'm able to grab the two different coordinates that I have, put them into a single location that stores all the data, and all that data is now inside a dictionary of places, which includes New York, and I can obviously put other places in it as well. But this is nice and clean, which is really nice. All right, now we can move on. Okay, let's continue. With help from the standard template library, add functions within the geography namespace that perform various calculations, like distance between two location objects and finding a location object with the maximum and minimum coordinates from a map. Okay, so again, quite a bit going on here, but once we know how to approach this, it goes by quicker than you'd think. So let's rename to exercise 7. All right. And some functions. Let's start with the easy one, which is the first. Distance between two coordinate objects. Not too hard. Now, I think we're going to just go by the distance in terms of the degrees. Probably you could do it in other ways, but we're going to keep things simple for now. So we are inside of the geography namespace here. And so we want to find distance. So let's think about what this does. It's going to calculate the distance. But what is the distance? Well, the distance is going to be a dependent on what the type is, right? If it's a floating point coordinate, for instance, it'll be a float. If it's integer degrees, it's integer. So I want this to actually be a template function. And so what it returns depends on the type. So it's going to be type, and this is going to be find distance. And now the parameters here are going to need to be two different coordinates. And what is a coordinate? Well, we're in the namespace already, so I actually can just say a coordinate, but specifically what kind of coordinate is it's a t coordinate, and this is C1, and there's another coordinate, C2. And now each of these has degrees, and so what we're going to do is if C1 dot degrees is greater than C2 dot degrees, then I'm going to return this one minus the other one. Otherwise, I'll do the other subtraction. So this way I don't worry about any negatives. Now, let's make sure I didn't mess that up. It seems like it's happy. Let's double check that it works. So right now I have, I guess this stuff is fine. So let's get a second location. Where is Toronto lat longitude? 4379. Okay. So we're going to do this again. This is going to be Toronto. Just so we have a second one. We don't need to declare places again. We've already got it. Don't need this extra print statements. They're not really necessary. And now what I want to see is, can it give me the distance between the two latitude coordinates? So let's see if I can find out. And here we do find distance of lat float and lat float 2. And then, okay, how about now? Oh, see, I mixed up the types. Oh, because these are pointers, and I need to get the actual coordinates. And now I have another problem, which is degrees is private, so this function can't access degrees, which means I should make it a friend function so that I don't have that problem. And so we'll do that over here, I suppose. And I can say friend. T find distance. Oh, it doesn't particularly like that. Oh, I think the function template. Add the 2 brackets after the function name here. I think I mixed. You know what? Actually, here's what we can do instead. This might be a messy way to do it. How about we just give a getter function, and we say t get degrees. Oops, degrees. And that way we don't have to declare a friend function. And over here, what we can do is we can actually say get degrees, get degrees, get degrees, get degrees. How's that sound? There we go. The latitude distance is 0. That doesn't sound quite right. So I think I messed up something while I was copying. Oh, I didn't put in the coordinates. 43.65 and 79.38. I have a feeling this isn't correct for New York, but that's okay. What is New York's? 4074, sure. Well, we'll correct the actual numbers. 4071 and 7400. Sure. The latitude distance is 2.94. Great. Okay, so that's part one. That is just the distance between the two coordinates. Now I want to find a location object with maximum or minimum coordinates from a map. And so here's where things get both complicated and not complicated, depending on how well you know your standard library. So we're going to have something that's going to give us a location. So again, this is going to need to be a template function. Type name T. What's it going to give us? We want to. So our map right now has a combination of strings and pointers to locations. So we want a pointer to a location. We want to figure out what is the location. So let's get a location T pointer, and it's find max location. And what are the parameters here? Well, the only parameter here that we really need is the map. And what is the type of the map? Well, it is, I guess we don't want it to be specific to floating point location. We kind of want it to work for any kind of map that takes locations. But now we're in a bit of a pickle because we want to make sure that we can handle any kind of location regardless of what it is. So I think what we're looking for here is a map from the standard library that takes a string and takes a location pointer to any kind of location. This is like a little messy, but when you break it down, oh no, sorry, it's a std string. When you break it down, in general, it's a map. It is going to take a string and a location pointer. Those are the things that it maps from string to location pointer. And we will call it, we can't call it map because that's already the name that's there. So let's call it, I guess, locations. Seems fine. Okay, and now you could do a lot of coding, but once again, we actually have something handy to help us from the standard template library. Now, I do believe that it may be in a different, I think it's in the algorithm library, if I'm not mistaken, just in case that's missing. But what I'm looking for is something to find, is it called find? Let me do a quick look up here. Oh no, sorry, max element. So rather than writing all the code to figure out the maximum thing, let's just use a function that's there and return the maximum element from our locations. However, what I need to do for this is I need to work out how the max element function works. So how does this thing work? It returns an iterator pointing to the element with the largest value in the range from first to last. So we're looking for, where is a sample? So here's a sample where they have it with an array. And so the, maybe this isn't the best example because this is just using arrays, and we have a map, and a map is not an array. So we need to have pointers to the start and the end. I don't know, I think the end might be optional, but we'll put it in anyway. So the start of this is locations.begin. This is an iterator the same way we saw with vectors. The end of this is locations.end. And now how do I figure out what the max is? Because you can't just take two locations and compare them. I'm looking for the max of their, let's say, first coordinate. So how do I do that? Well, I need to give this a function, actually. And we're going to need to make a function that compares locations of type T. And then what this will do is this will compare the locations. But specifically, I'm not looking at the string location pairs. I'm actually looking at, I want to get the location at the end. So I believe if I, let's actually go and do our compare location thing first. So for this to work, I need another template function. And this is going to compare location. It's going to return a Boolean because it's either greater or less than, right? So compare location is going to take a pair. So maps in general contain pairs. A dictionary is a bunch of pairs of keys and values. So everything in a map is a pair. And there's going to be two pairs I'm looking at. One is the string location pair of the first element of my array of my map, and the other is the second one. So I'm looking at, for instance, New York, its coordinates, versus Toronto, its coordinates. So those are two pairs that I'm matching up. So the types of pairs are string and location pointer. And this is going to be location 1. And the other one is the same thing, location 2. And between these locations, what I'm returning is, for these pairs. So this isn't location 1, this is pair 1, and this is pair 2. So for pair 1, I want to grab its second thing, because the first is the string, which is worthless. I want to look at the location itself. So for that, we will, and now here's where we're probably going to need to add another getter, because right now I can't get these coordinates. So let's do a getter. I suppose I could overload the substring operator is one option. So that would be a coordinate t pointer operator subscript index, and it would return coordinates index. And so this means now I can get the coordinates from a location, or get any coordinate from a location. And now when I'm comparing them, for my pairs of New York and then the New York location, get the location. For that, take the first coordinate, get the degrees, and then see if it is less than the other one. This function now can compare any two string location pairs, New York location and name and coordinates and so on, Toronto location coordinates and so on. Compare the two of them, see which one has a higher value for its degrees of that first coordinate. Now that I have that function, I can do what we have down here, which will find us the pair of my map which has the greatest coordinate. But I don't want the pair, I want the location. So I will grab the second of these. Okay, so I did this correctly. Let's see. Well, which one has a higher first coordinate? It should be Toronto because it's 43. So what we will do is we will use our find max location, and we will assign that to a variable, and then we will print it. So this is a float location pointer greatest equals find max location of our places. Greatest arrow print. Let's get rid of some of these extra prints that are here. Let's see if this works. Okay, what have I messed up? I forgot the STD before end line. That's an easy thing to fix. What's my other mistake? Base operand of arrow has a non-pointer type. Oh, the second thing from here is not a pointer. It is just a location. So I can do dot get degrees. Okay. Dot get degrees. Dot get degrees. Location float does not have a member called get degrees. Oh, right, because that's I'm bungling this. Shouldn't it? What is it returning? It's returning a It should be returning a coordinate, and then coordinates have a get degrees. Okay, what have I messed up here? Non-pointer type geography location float, but it shouldn't be a location float, right? It should be a coordinate. I wonder if this was not done correctly. Did I mess this up? I hope not. Let's see. What happens if I do the following? Pair 1, second, 0 gives it a coordinate. I wonder if this is the problem of trying to do this on a pointer, but that should be okay. Here's what we'll do. To verify that this is working correctly, I'm going to try to access, with a subscript, the coordinate from one of the things down below. So instead of doing this, what we'll do for a moment is actually go places, Toronto, so this should get me the location. And then from here, I should be able to grab the first coordinate and print it. Sorry, this gives me a pointer, right? So it should be arrow print. No, okay, so something wacky is going on here. Okay, of course compare location was not declared. I haven't done the thing properly. I feel like I messed up something with this overloaded operator. Coordinates index. It said this was okay, but it doesn't seem to be doing it. Let me think here. Let's do a getter and see what happens if I do that instead. So instead of overloading this operator, although I do want to know why it's not working. So basically the thing that I messed up here is that for some reason it's not letting me do this, although it should. Overload subscript operator. Oh, I wonder if it's looking for a reference? It could be. Does this make a difference? Let's see. No, see, it's still the same thing. Non-pointer type geography location float. It still thinks that the 0th element of my coordinates is not a coordinate, and it thinks that it's a floating point location, but it's not. It's a coordinate. Let me see. Oh, I see what it is. Okay, okay. So, this is a very small, minor thing, but it ends up making a big difference. So, when we were using arrows and stuff to refer to the members of a pointer, trying to access the subscript operator from a pointer means you have to write it a little differently. Rather than writing things this way, which I have, you actually need to access the location at the pointer before getting the subscript operator. And suddenly everything is coming together. So let's pull things back to where we were trying to fix things. And here, before I access the subscript operator, dereference it. And this should solve our problem. And look at that. The greatest location is Toronto. And now the nice thing is, because we got this working, we actually can find min location by only changing a couple letters. The least is find the min location, and the least location is, oh, I should have both, just to make sure that they're both doing the thing. The least location is New York, the greatest is Toronto. And just for the sake of testing, how about we throw in one more to make sure everything is working okay. So, let's throw in one more location. Let's do, how about Rio? 2243, sure. So this is Rio, flat flow 3, flat flow 3. And let's see how our answer changes now. Rio is the greatest. Rio is the greatest? That doesn't sound right. Oh, because I forgot to pass it 3 and 3. That would be why. There we go. The greatest is Toronto, the least is now Rio, because 22 is below the amount for New York. So there we have it. We've completed a few functions that all are taking full advantage of the standard template library, accessing the max element function, using iterators to compare locations. The map contains pairs. Each pair is a string, which is, Toronto, so on and so forth. Yeah, the second being the pointer. And because the pointer is the second part of my pair, I have to dereference it before I can use my subscript operator, which I overloaded here, to grab an actual coordinate. All right, we're almost done. There is one more to go. Okay, last but not least, duplicate into exercise 8. For exercise 8, we're going to create a template function inside the geography namespace that can find and return the maximum and minimum values from a vector of comparable data types, including coordinates. So let's take a look at how we're going to do this. So if I want to be able to compare coordinates, right now I can't because there's nothing for that. So I'm going to need to overload an operator here. This is also going to need to give me a Boolean. operator. Let's say we'll do less than. I think this is the only one we'll need for this. And we're going to need a coordinate of type t, which is other. A pointer will suffice. And all we're doing is we're returning degrees less than other arrow degrees. Simple enough, so now I can compare two coordinates. Everything okay so far, compiler? Seems happy with it. All right. Now that I can compare coordinates, I can compare integers, I can compare floats. Let's make a function inside my geography namespace, which is going to be called, and so this is also a template function, because again, I don't know exactly what type I'm going to be comparing, but I want to return the minimum and the maximum. We've already seen that pairs allow us to do that. So this is going to be a pair, and the two types inside the pair are both t, because it's whatever types I'm comparing. And this is going to be find max min given a, and so this one said it is a vector. So we're going to need vector. And inside of our vector, we need to have of type t objects. And this will be our objects, for instance. Okay, so we're again going to leverage a few things here. First is going to be something that is going to be so what's the type of this actually? I'm not quite sure. So I want to get a pair. I think it's a pair of t. But we're going to use the min-max element method. Maybe this will tell us what the type is that it returns. Oh, it's going to have some iterators. Okay. Does this example tell us? Okay. So this example uses a bit of a cheat, something that we haven't used before, but I think now might be the time to do it. And the cheat is called auto. So up to this point in the course, all of the variables that we've made are strictly defined. We say this is a integer, this one is a float, so on and so forth. But the type for this, I think, is something kind of messy. I think it's like some kind of combination of iterators and t or something like that. Where does it say? Return value is a pair consisting of an iterator to one thing and an iterator to the other one. So I suppose you could maybe figure out exactly what kind of iterator it is. I think it's like iterators with t in it somewhere. It's a bit of a mess. And so there's a shortcut, and I think we'll use the shortcut now. And the shortcut is that actually we can say that this is a auto. So you can see it turns in green, and this just says figure out what type this is supposed to be and make sure this variable is that type. And this is going to be the min-max pair. And it's going to use this method. So it's going to take an iterator, so objects.begin, objects.end. And it's going to go through and find a iterator pointing to each one. And that way I can just, oh, do I have the right number of parentheses? Yeah. I can just, why does this not seem to, there we go. Return make pair, which is also a standard template library method. And I want to make a pair using the min-max pair, which has a first and it has a second. Okay, compile okay, we're all happy. Oh, some things are unhappy about this. Vector was not declared in this scope. I sure hope it is. I defined it up here. Oh, it's std : vector. That would be why. Okay. So everything seems happy so far. So now this function should actually give us a pair containing the lowest and highest of coordinates. So let's put some coordinates in. We have all the coordinates that are here. We can see pretty quickly that the 79 is the biggest and the 22 is the smallest. So let's put all of these into a vector. I think the vector right now, the way that we set it up does it have pointers? Oh no, it's of type T. And now I think I can compare the pointers. It should be able to do that. Yeah, it looks like it. So let's try it out. So we'll ignore all this. I'm gonna make a vector that takes float coord pointers. We'll call it coords. And we'll do coords.pushback. All of these. Lat float 1, 2, and 3. 1, 2, 3. And long float 1, 2, and 3. Everything okay so far, compiler? No problems? Okay, so this now has all the things in it. Now I should be able to get a pair and this is a pair of float coord pointers. Max min is going to be find max min given my coords. Is that okay? Can I do that? Am I fine with this? Oh, not happy. Why are we not happy? Could not convert this. So I think I have the wrong type here. Oh, and I think I know what the problem is that this is a pointer, I believe. So I need to dereference it to grab the first and second. Yeah, there we go. Same kind of issue as before, is where we're trying to grab the first and the second, but the min-max pair thing here they're iterators, so I need to reference them. Okay, so now it was able to do this, and so now I should have a pair of the two floating point coordinates. So let's do the max is, and then we'll do max min first print. Min is max min second print. I think it's the same thing here. I might need to dereference this. Oh no, actually max min is not a pointer. This is just a pair. So I can just do dot first, dot second. There we go. Okay, so it didn't do so good here. The max is 40.71, the min is 43, but that's not quite right, is it? So why is that? Let's see if we can work it out. Is there a mistake that I've made with my comparison? I don't think this matters, but just in case, let's make it other dots. Let's see this without pointers. Does that make a difference? No. Okay, so that didn't matter. Thinking. Lat float. Oh, I think I might know what it is. find min-max does already exist. It's, I believe, from something else. What I'm looking for is the one that I just made in geography. Nope, that didn't help. I'm surprised that that didn't even come up. I would have thought that surely should have been a thing that that appeared. Find max min, right? Yeah. Max min. And somehow I ended up with 43. Thinking. Apologies if this is not the most exciting video to watch me ponder about why this didn't work. Let's see if we can debug a little bit, huh? First, let's check that our vector contains everything we think it does. In towards speed up, C arrow, print. So it contains all of the degrees that we thought. Okay. That's a good first step. Now here, it doesn't seem to construct this properly. Something is wrong. Given my vector, it should be going through and finding the maximum and min, but it doesn't seem to do so. What does min-max element do again? Find the smallest and greatest. A pair consisting of an iterator to the smallest and an iterator to the greatest. It returns make pair first if it's empty. And make pair, I wonder if what I've done here is redundant. I wonder if I could just do, if I could just combine all this. Let me see. What if I just do this? Oh no, so I think the reason that this doesn't work is because I'm returning iterators, but I want to return the things themselves. So this is a pair of iterators, and so I want, maybe I want what's at this? What's at this? Is that the issue? No, still not doing it. And comparing to the other one, I'm thinking it might be the case that simply, so here's what I think is happening. It's giving me 40, 71, and 43. Why these two particular numbers? Well, I happen to notice that one of them is the lowest in address and one of them is the highest address. I think what's actually happening is it's not really finding the min-max. I think what it's doing is it's finding the greatest and lowest addresses of my pointers, which is not particularly helpful. So what I need to do is I need to modify this so that it will work with pointers. So my pair here is a pair of pointers. I think I want it to and so over, where is the compare? Yeah, okay. How does this do? Where's the problem here? Oh, I think I'm not supposed to dereference these now. Oh no, sorry, this is a vector of pointers to some type. Missed the semicolon? Oh, I have an extra parentheses there. There we go. Okay, clear this up. Okay, this make pair thing is still messing up. What is the problem? Do I need to dereference this first? Okay, this did not work. I think it has to do with this, where I'm comparing the two things. So what if I make this so that, let's say that we make it so it doesn't work with pointers, and we just say, you know what, this will only work if you put in the actual things. If that's the case, I should be able to shorten this actually. So over here, let's push back into this vector the actual things. And the pair will be objects and so on. And I think the issue that this wasn't working is because it's all trying to work with pointers when it should be trying to work with the actual coordinates. Okay, so I've jammed everything into my vector, trying to find the biggest stuff. We'll see if it prints it out. Over in my min-max, I've removed all instances of pointers. Let's see what happens now. Whoop, it's still unhappy. It could be the case that I don't have to, I might still have to put these in here. Okay. There we go. Okay, so let's, just to recap. When I was trying to figure out the greatest and lowest coordinates of my 6 coordinate pairs, it wasn't using the coordinates, it was comparing the values of the pointers, which are addresses. The first address being this one, and the greatest address being this one. This is not helpful. I don't care about what order I declared variables, and I want to know the numbers, which is biggest, which is smallest. There is a way to get around this and still use the pointers, but I kind of just want this to work. So instead, I've created a vector that doesn't have pointers. It's a vector of actual coordinates. The real numbers are here. And inside, I push the contents of all of my pointers to these coordinates. So this is the actual thing. Now that my coordinate vector has the actual coordinates inside, I can use my find max min function, which probably should be called min max because it gives the smallest number first. No, let's correct it, I guess. Find min max. Find min max. There we go. And my print should be the other way around. Min max min max. Just fixing the order up a little bit. There we go. Hooray, min and max. Okay. This function, which I've created up above, inside of geography, by the way, goes through a vector and uses the min-max element function from the standard template library, given the iterators that point to the start and end of my vector, to find a pair containing the min and max elements. I want to make that pair and return it. And so this thing here is a combination of iterators. It's an iterator. It's a pair of iterators. One iterator points to the first element, one iterator points to the second element. I don't want to return a pair of iterators. I want to return the things. So I dereference the iterator, and I get its first thing. I dereference the iterator and get the second thing, and now suddenly I am where I want to be. I believe this is iterators, right? What is min-max element? Oops, that's not what I wanted to put. This one. Yeah, a pair of iterators. Weirdly, it looks like it's a pointer to a pair of iterators, but in any case, I grab my pair of actual coordinates, and now I have my lowest and my biggest. May have been a bit confusing, which is why I definitely encourage practicing this a little bit so you can see what happens when you modify certain parts of this. There really is no way to master any of the content I've talked about today without doing a lot of practice materials, so try to do so. That's it for this video. Thanks for watching, and I'll see you in the next one. Bye-bye.